Okay, introduction to organic chemistry. Organic chemistry revolves around the element carbon on the periodic table. Carbon is the element that holds it all together. Organic, the word came, you go in HEB right now and you see there's organic apples and there's organic celery, and where'd that word come from? Well, 100 years ago, they really thought that they knew that molecules you get out of living systems, tree trunks and leaves and protein and whatever, is carbon-based. So carbon-based chemicals were deemed to be chemicals that came from living organisms, came from nature. Except things like carbonate, calcium carbonate that's in our water has carbon in it, or CO2 that we are exhaling, it is considered an inorganic molecule. But anything else had carbon in it was, that came from a living system. In fact, the first chemist that synthesized in the laboratory a carbon-based compound was laughed at. It's like, you can't do that. Only living things can do that. So when you relate the word organic to living, that's where it came from. But more recently, organic chemistry relates to man-made molecules. They're molecules that man synthesized, men or women, but man-made compounds not coming from nature. Aspirin doesn't come from nature. Ibuprofen, Tylenol, they're carbon-based. And in many cases, for example, aspirin is related to salicylic acid. That comes from nature, but we've modified it a little bit. So it's now synthetic. And actually, the synthetic chemicals have many more side effects than the stuff that comes from nature. So that's the history behind the word. The study of carbon compounds, like I said, the exceptions are simple things like carbonates, carbon dioxide, carbon monoxide, cyanide are some of the inorganic carbon-based compounds. But everything else is pretty considered organic. You're going to find, going to do a week and a half of this, carbon-based kind of synthetic chemicals, and we're going to look at biochemistry and carbon-based things like glucose. Carbon-based, comes from nature, but it's a carbon-based compound, but it's biologically active. So when we get into biochemistry, we're going to be looking at biologically active carbon-based compounds. So it's going to be really kind of neat, because you're going to learn all these different organic groups here, and then you're going to start seeing them show up in biologically active molecules. These are going to be a little bit more creative. We're going to look at a molecule and say, oh, there's two different organic functional groups on that molecule. Well, that's the way nature works it. So let's, on the organic side, foods, well, that's biochemistry. Here's silk, linen, wool, cotton. Those are all naturally occurring fibers. And then you get to Dacron, nylon, Orlon, man-made fibers, synthetically made fibers. Plastics are organic compounds. So your water bottle, plastic, comes from crude oil. You believe that? Can you believe something you can look through so clearly? Comes from crude oil. It's itself an old drum of black crude oil, but you can distill out of it ethylene. So you distill the ethylene out of there, or crack it out of there, convert some of the crude oil to ethylene, distill it nice and pure, and turn it into polyethylene. And you can see through it. Pharmaceuticals, detergents, pesticides, gasoline, and oils. natural gas, methane, propane. Organic chemicals are all over the place. And when I say plastics, all this plastic. We live in the plastic age. This box, the computer, the keyboard, all plastic. These markers, all kinds of plastics. Okay, here's where I want us to fill in some blanks. So I'll hand this out. This is two-sided. So turn it over to where you see very at the top, alkane. All right? Okay, now, I tell you what, I don't really expect you to, I'll tell you what I do. I took a little course here. Lisa had a book in there, and I said, well, how do you deal with intensive courses? 3-week, 4-week, 5-week courses. They said it's good for the students to have something to kind of hang the course on. They say, oh, hey, here's where we're going. Okay, so that's what this sheet of paper is. You don't need to know this by Wednesday. But we're going to go through real quickly right now so that you kind of can say, oh, here's where we are. Here's where we're going next. This is what this is all about. And I don't know if I can reach up that high, and I don't think there's any way for me to make this. Oh, look at that. Beautiful. All right. So we're going to fill in some blanks here. And over here is the chapter. All right? So this is chapter 10. This is 11. And this is 12. So what are alkanes? The alkanes are like, if you went into 31 different flavors, I've done this. Gone in and what would you like? I'd like a scoop of vanilla. A vanilla. Yeah, okay, we got vanilla, but we got 31 different flavors. Vanilla. I'd like some vanilla ice cream. Well, that's our vanilla ice cream. Okay, that's just our plain vanilla ice cream. What's it have? Carbon-carbon single bonds. It's saturated hydrocarbons. And the most exciting thing we do with those is burn them. And that's what we do with alkanes. We basically burn them. Your gas tank is full of alkanes. Aviation fuel. The propane tank at home. And your grill. The methane coming into your house. Those are all alkanes, and we basically burn them. We will just talk about one other thing. X is a halogen. So you might want to take a few notes on here. And what are halogens? Well, there's fluorine. We'll just put fluorine, chlorine. And they are diatomic. This is how they are as an element. Chlorine is like that. But when you see it on a carbon compound, it's a single bonded to it, and it's called chloro. That's what I'm trying to tell you right there. You take the chlorine and you're going to change it to chloro, bromo, iodo. Don't you like that, iodo? Sounds like Star Wars. All right, so that's chapter 10. Chapter 11, we've got alkanes. We have, okay, what do alkanes have? They have carbon double bonds in them. That's the functionality. That's the thing that reacts differently than carbon-carbon single bonds. Carbon-carbon double bonds are different. And they react differently. So we say that is the functional group in alkenes. That's the group that dictates how that class of organic compounds is going to function. Follow me? So that's the functional group. And the name of that one right there is ethane. Ethane. There are many others. That one just has 2 carbons. It's ethane. Then fill this in. These are alkynes. YNE. Here's what I should have put in here too. I don't know. This would have been nice. Ene, and it's a carbon-carbon double bond. Ine. I got a dash there. What's that mean? Well, if we have an alkyne, we're going to put YNE on the end of the name. You're going to know. You're going to look at the end of the name and go, oh, I know what class that belongs to. You go home, you look at a bottle of mouthwash. If you have any mouthwash there, and it says there's menthol in this mouthwash. You're going to know that menthol, all O-L, I bet that's an alcohol. I bet you're right. Alcohol. That's a function. That is a class of organic compounds, an important class of organic compounds. And the functional group is the OH, or hydroxyl group. And the naming is an OL. In chapter 12, we'll also look at ethers. Ethers is a class, dentists used to use ether to anesthetize a patient before drilling a tooth or whatever. They use a particular compound, but that is a class of compounds. And what's the functional group? A carbon-oxygen-carbon bond. So that's chapter 10, 11, and 12, and that's the exam on Friday. Are you filling all the blanks? Let's go on to the next one.
Excuse me.
Yeah.
When you have the alkane group, you have the double bond, but you have ethane there. Is it supposed to be ethane, like E and E?
Here?
No, the last was the N. Where you have ethane? Up.
YL.
On the alkane.
On the alkane.
No, not alkane. Alkane.
Alkene?
That, down to your right. Where you wrote ethane.
I had alkyne.
No.
What do you want?
It's ethane instead of 2.
Is it supposed to be E and E? The last 3 words.
Yes, Blessing. You're right. That's wrong. That's wrong. That's ethene. Ethene. There's ethane up there. Is everybody using pencil? Not on this one, huh? All right. If I ruined it, I got 2 left. Sorry. That's right. That's ethene. Exactly. That's the way it should end. Good catch. Very good. Okay. Gotcha. All right. I gotta pay attention to Blessing's questions. All right, let's look at this second one. Aldehydes. Let me move this down so I can. So this is chapter 13, right there. This is chapter 14, and this is 15. This isn't the whole course. This is the organic portion of the course, is where you can hang your hat on here. Aldehydes is going to have something like this. So we'll put carbon there. There's a carbon-oxygen double bond with a hydrogen on that carbon as well. That's aldehydes. And you see, they're going to end with that. We're going to take the Al of aldehyde and we're going to put it on the end of the name. You're going to know it's an aldehyde. We're going to take the ONE of ketones and use that there. And I'll put that. That is, you're going to have a carbon-oxygen double bond. The reason these are both in the same chapter, they both have a carbon-oxygen double bond. But this one, the carbon-oxygen double bond, is on the end of the molecule. That's an aldehyde. And here it's in the middle somewhere, and that's a ketone. Carboxylic acids have a carbon-oxygen double bond, but they also have a hydroxyl. So that's a carboxylic acid. And oic acid, we'll get into that later. How do you name those? But the OIC acid, we will actually use the name, we'll add the name acid to it as well. Esters, what are esters? Esters have this functionality. See, they don't have an OH, they do have an O, but that O doesn't have an H on it, it has a carbon on it. That's an ester. Those are great. So it took you in HEB. Well, we'll get that when we get to chapter 14. All right, now chapter 15. Now, so far in chapter 10 and 11, it's carbon and hydrogen almost exclusively. 10 and 11. 12, 13, and 14, we introduce oxygens. And oxygens have a lot of variety in terms of organic molecules that you can make once you start incorporating oxygens. You can make alcohols, aldehydes, ketones, ethers, carboxylic acids, esters, just carbon, oxygen, and hydrogen. Now down here, we're going to add nitrogen. And we're going to have, the first thing is amines. The amine there's going to be a nitrogen, an NH2 group, or an NH, or something like that. Dimethylamine. I got that there, so let's see. If I have dimethylamine, I better put it on here. This would be dimethylamine. These are all hydrogens. That's dimethylamine. And then amides or amides are going to have this kind of structure. An oxygen and an amine. So that right there would be a ethanamide. Got two carbons. You got a carbon, double bond to an oxygen, and then an NH2, and that's a ethanamide. Okay, let's take a 5-minute break and come on back, and we'll pick up with alkanes. Then I'll jump into alkanes, and we'll start really learning what we need to learn about alkanes. I think we're doing great. We may have this course done by this afternoon. No. Okay?